Hello everyone. Today the topic that we're going to discuss is comparison of NoSQL database. So the topics that we're going to discuss are introduction to NoSQL databases, key value database, document oriented database, column oriented databases, graph databases, and then comparative analysis, then the conclusion. So introduction to NoSQL database. So the definition of the NoSQL is NoSQL, which is also called as not only SQL databases, are a category of databases that diverge from the traditional relational database management system, which is RDBMS. They are designed to handle large volume of structured, semi-structured, and unstructured data. And NoSQL database offer flexible schema diagram designs, horizontal scalability, and high availability. Why SQL? Why NoSQL? So the traditional relational database may face challenges with scalability and performance when dealing with massive data sets or a distributed environment. So NoSQL databases addresses these challenges by providing various data models and distributed architecture tailored to specify use cases. So the characteristics of NoSQLs are schema flexibility, horizontal scalability, and high availability. So then when to consider NoSQL? So some of the real-time examples are big data applications. So NoSQL databases excel at handling large volumes of data and high velocity data integration. So real-time analytics, NoSQL database support fast and read write operations, making them ideal for real-time analysis and processing. Then in web and mobile applications, so NoSQL database provides flexible data model that align well with the need of web and mobile application, which often deals with diverse and rapidly evolving data. So some of the examples of NoSQL databases are, so for the key values are Redis, Amazon, DynamoDB, and for the documented oriented database, the examples are MongoDB, then Couchbase. Then column oriented are Apache Cassandra, then HBase. Then for the graph examples are Neo4j, Amazon Neptune. Now coming to key value database. So the definition of key value database is key value database store data as a collection of key value pairs. So each key is unique and is associated with a value, which can be simple string, binary data, or more complex structures like JSON objects. So examples of key value databases are in Redis, an open source in-memory data structure stores known for its high performance and versatility. Then in Amazon DynamoDB, a fully managed NoSQL database service provided by AWS, offering seamless scalability and low latency performance. Then the use cases are session management, storing user sections and session related data for web applications. Then caching, storing frequently accessed data in memory to improve application performance. Then real-time analytics, recording event data for real-time analysis and reporting. The pros and cons of the key value databases are, so the pros are high performance, scalability, and simplicity. And the cons are limited querying capabilities, data modeling challenges, then lack of ACID transactions. Then coming to the next slide, which is document oriented database. So the definition of document oriented databases are, so it stores data in flexible semi-structured document, typically using formats like JSON or binary JSON, which is BSON. So each document can have its own structure, allowing for nested field and arrays. So examples of documented oriented database, MongoDB and Couchbase. Use cases include content management like storing and managing content for websites and our application with varying data structures, and then catalog management, Then for the personalization, like capturing and analyzing user preferences and behavior to deliver personalized experiences. So the pros are flexible schema, rich query capabilities, horizontal scalability, and the cons of the um, document oriented databases are data duplication, where denormalized data models may lead to data duplication, so requiring careful management to avoid inconsistencies is required. Then complexity in querying, then storage overhead. So next, coming to the next slide is uh, column-oriented database. So the definition of column-oriented database is it stores data in columns rather than rows, allowing for efficient read and write operation on large data sets. So each column is stored separately, enabling fast data retrieval and aggregation. So the examples includes Apache Cassandra, then HBase. Use cases of these databases are time series data, where storing and analyzing data with timestamps such as logs, sensor readings, and financial transaction. And then the analytics and reporting, so performing complex analytical queries, including aggregations and filtering on large data sets. Then the pros of these datasets are high performance, compression, and scalability. And the cons of these databases are write performance, complexity in data modeling, and then limited transaction support. So graph database. Graph database stores data in nodes, edges, and properties, allowing for efficient representation querying of a relationship between entities. Nodes represent entities, edge represents relationship between entities, and properties provide additional information about nodes and edges. Examples: Neo4j. It is a leading graph database known for its expressively query language, cipher, and native graph storage. And another one is Amazon Neptune. It is a fully managed graph database service provided by AWS. The use cases, social networks like modeling relationship between users, post comments, and other entities in social networking platforms. And then it is also used for the recommendation system, for like analyzing user preferences and behavior to generate personalized recommendation for products, contents, or connections. And then for fraud detection, identifying suspicious patterns and relationships in financial transaction or online activities. Then the pros of these databases are relationship centric data model, flexible schema, and graph algorithms. Like many graph database provide built-in support for graph algorithms such as the shortest path, centrality, and community detection. The cons: scalability challenges, query complexity, performance trade-off. So coming to the next slide is the comparative analysis. This is where the difference are told, mentioned. So coming to the first one is data model. So in the key value database, it is simple key value pairs, and in the document oriented, it is a semi-structured document, and in the column oriented, it is data stored in columns. In graph, it is stored as data models is of nodes, edge, and properties. Coming to the scalability, where key value pair is highly scalable, document oriented is horizontal scalable, then column oriented is horizontally scalable, then graph is also scalability may vary. Then querying capabilities. So the querying capabilities of key value database are it includes basic CRUD operations which create, read, undo, delete operation, and in documented oriented it, querying capabilities as rich querying capabilities, column oriented optimizer for analytical queries, then in the graph specialized querying language. Coming to the performance, key value is high read or write performance. Document oriented is fast read or write performance. Then column oriented is excellent for analytical queries. Then graph, it depends on, yeah, performance may vary. It completely depends on the data model. Then consistency. Consistency of the key value varies eventually, like strong, eventual or strong consistency. Even in the document oriented also it varies eventual or strong consistency. So in column oriented it is typically eventual consistency. So in graph it also varies, either it is eventual or strong consistency. Then coming to the use cases in the key value databases, caching, session management, real-time analytics. Then coming to the document oriented, it is content management, personalization, catalog management. And in the column oriented, time series data, analytics and reporting, and HOC querying. In the graph, social networks, recommendation system, fraud detection. So coming to the last slide is conclusion. So the key takeaways. NoSQL database offers a diverse range of options tailored to different data management needs. Each type of NoSQL database, uh, which are key value, document oriented, column oriented, and graph, has its own strengths and weaknesses, making it suitable for specific use cases. So, understanding the characteristics and trade off of each type of NoSQL database is crucial for choosing the right solution for your application. And recommendations. So for application requiring simple data storage and fast access, key value database like Redis or Amazon DynamoDB may be suitable. And documented oriented database like MongoDB or Couchbase are ideal for application with flexible schemas and complex data structures. Then graph databases like Neo4j or Amazon Neptune are essential for application involving complex relationships and graph-based algorithms. So then future trends. So NoSQL database continues to evolve with advancements in distributed computing, cloud technology, and data processing frameworks. So trends such as multimodal databases, serverless computing, and real-time analytics are shaping the future of NoSQL database architectures. So keep an eye on emerging technologies and consider how they can enhance your data management strategies in the future. So in conclusion, choosing the right NoSQL database involves understanding the unique feature and trade-off of each type of and aligning them with the specific requirements of your application. So by staying informed about the latest trends and advancements like in NoSQL database, you can ensure that your data management strategies remains effective and future proof. Um, Thank you. Have a nice day.